Okay, so version 8.4 of the Tycho software is now available, and as usual, I thought I would go ahead and put together a short video to go over the new features and enhancements to be expected in this release. So first off, we have a new Crossmatch feature. This takes in two track files produced from two different cameras of the same field taken at the same time, and the idea here is to essentially eliminate all false detections with this approach. This is still somewhat of an experiment, but it's worth investigating, so it's now an available option. Next up, we have the ability to show active comparison stars. This is useful for photometry users to get a quick glance at what comp stars were used in a given photometry set. Then we have new overlay options for Palomar Sky Survey images, new command line options, a new diagnostic tool for the find orb configuration, higher quality measurements, and finally the ability to specify how output files are placed. So with that out of the way, let's go ahead and get started. Okay, so one of the new features is the ability to specify the output directories where the data has been processed. So if we go to Settings, Image Directories, then you can specify whether or not to place the output adjacent to the original input directory, which is the default behavior, or to place the output inside that input directory. So the typical behavior is to place the output files adjacent to the input directory. So this would be the original input directory, followed by calibrated, aligned, and so forth. So each step in the process will have a corresponding output directory. But now, as an option, you can have it where Tycho will output these files inside that original input directory. And you can also now have the ability to automatically load the output files into the image manager. Another new feature in this version is the ability to display the active comparison stars. So as an example, if I right click on a photometry set and choose Load Comp Stars, it will present with a new window showing the active comparison stars. But at this point, we can also now have the option to show these active comp stars within the image manager. So if I choose this option here, then it will visually display these active comparison stars. So this is a great way to just get a quick visual inspection of which comparison stars were used for that particular photometry set. Another new feature in this release is the ability to perform diagnostics on the find orb configuration. So if I go to Settings, Find Orb, first off you will notice that it has been streamlined a bit. Whereas previous versions you had to specify the path to 3 different find orb executables, now you only have to specify the path to the modified find orb executable. And there's also now a diagnostic test that can be performed. So if I click on Run Diagnostic Test, what it's going to do, and what it just did there, is validate the path to this executable and also retrieve some information to ensure that it has a supported version and that it is also able to write to that directory. So if there is any issue at all, then you should be able to determine the cause of that issue from this diagnostic test. The Palomar Sky Survey overlay now also has 2 additional configuration options. So as an example, one use case for this feature is we have a star that went nova. So if we want to pull down the previous images to that occurrence, we can right click and choose View the Palomar image, and it's going to download that image and then display it as an overlay on top of an existing image that you've taken. Now usually that overlay will be spot on using the WCS information within your images. However, there may be times when you need to adjust these parameters to get the overlay centered correctly. So previous version we had rotation and scaling. now with version 8.4 we have the ability to translate in X and Y. So as you can see here from the difference mode, we are able to see both the old image and the new image simultaneously with the red-green coloring. So what we want to do is have these line up, and so we can adjust in the x-axis to where they are pretty much one-to-one. So this gives us a better fit, a better overlay. So if we do now a fade option here, you should be able to see this transition from the old image to new, so you can see this nova occurrence more easily. So this gives a nice, again, these two additional parameters give a nice customization of the overlay. There are also several new command line options available in this release. This includes the ability to calibrate images, resize them, align them, merge them together, or do a cross-match. So for example, alignment can now be done on the command line. So it requires at least 9 arguments with an optional reference index. So if you wanted to know how to do that, the Tycho user guide goes into more detail on that. So all of these options now are available on the command line, and I suspect a future version might expand on this list as well. But for now, for example, alignment can now be done on both command line as well as through the usual user interface here. Another notable enhancement in this version is the quality of measurements. So as one example, here is an object it's a moving object, and if I go ahead and animate the frames, you can see it more clearly. So here's that object, and these are not the best quality images. You can see that the object has sort of an egg shape on some of these images, but nevertheless we would still like to be able to generate the highest quality measurements that are possible. So what I'm going to do here to illustrate this enhancement is I'm going to create a track of this object. So create marker 1 on the first position and marker 2 on a second position here, and just go ahead and create a track from markers. And if I double click on it, then you can see an animation of 3 different substacks. So here is the object here, and the way it typically would work at the previous version when you did verify track. So if you wanted to create measurements of that object position, the way it would determine which layer to use, or which substack layer, it would either be median combine or it would be the above layer. It would determine that based upon the movement of the object, so what kind of distance the object traversed. So for example, if we go back to that first position here, so if the object had very little movement, then the program would select the median combine layer. On the other hand, if the object moved had more notable movement, then it would choose the above layer. And that's because typically 99% of the time the above layer will work better in crowded fields. And in fact, this is an example where the object passes in front of a star, so you would like to avoid interference from that star. So again, going back to the track, the animation here, you can see it's passing in front of a star, and if I choose the above layer, then you see that for the most part all of the star interference is mitigated. But this is one of those 1% of the time where the above layer is actually suboptimal because the image quality, it just does not present as good of a centroid. So the fix for that is that with version 8.4, it now automatically it generates the 3 measurements for both different layers, and then decides it does a calculation to determine the quality of measurements from both, and then determines from that, it compares the two and selects the one having the best quality that way. So that was not done before because it's very time consuming, or it was very time consuming to compute these measurements. And if you had hundreds of objects in a track, it would take a lot of time to do that for both layers. But now it's been optimized. It's actually 3 times faster with this version compared to with version 8.3.1, and that version itself was twice as fast as the previous version. So it's gotten a lot more optimized in computing measurements. So being able to take advantage of that, we can now go ahead and essentially just go ahead and compute for both the above layer and the median layer and select the one having the best quality. So version 8.4 has now that kind of improvement with the measurements. And if we wanted to evaluate the actual quality of these measurements, of course we can go ahead and add observations of this object. So go ahead and give it a designation. This is object number 470. So I click OK, and we wind up with 3 different measurements here, one for each substack. So if you want to, you can zoom in. You can see the green crosshairs represent the computed centroid, and you can see that for all 3 substacks. So this looks pretty good on visual inspection, but then the way to actually know for sure is to compare these measurements with other measurements from different observatories. So I'm going to download observations that are of this object, and this is a low numbered object, so it has a whole lot of observations associated with it. So I'm going to truncate to the past 5 years. That will speed up the comparison. These messages here, that just means that I don't have, this is a brand new observatory that was added a few weeks ago. I can ignore that. So we'll go ahead and let FindOrb compute the residuals, the error of these measurements. So as you can see, 0.14, 0.35, and 0.19. So 0.35 arc seconds was the highest residual from the 3 that we submitted here. So 0.35 is a very good measurement. So these are very high quality measurements. Even though these images themselves might not have been the best, we were still able to compute a very good centroid and correspondingly a very good astrometry of this object. So that's the idea with version 8.4, is that it's able to make a more intelligent decision on how to compute the best possible substack for measurements. And finally, the last feature that I will talk about in this video is the new Crossmatch functionality. And what this does is it will take 2 track files generated from 2 different independent cameras and then perform a crossmatch to essentially eliminate all false detections. So the only tracks that survive the crossmatch will be those associated with true real objects. So here's one example of that where I've done a crossmatch on 2 different track files, and I produced a 3rd crossmatch result. And so every single track in this list is that of a real object. So this is still somewhat of an experiment, but the idea is that if you had 2 telescopes, 2 cameras, you could have them image the same field simultaneously and do a cross-match of their detections. And that's basically the way to look at it, is if you have 2 cameras, you have basically 3 different options on how to use them. One is you can get more sky coverage, so you have double the sky coverage with twice as many telescopes and cameras, or you could have an improvement in the signal-to-noise ratio. You could stack pairs of images of those 2 cameras. So these images would have been taken at the identical time, and so you could simply combine them together prior to doing the synthetic tracker, and that combination of these pairs of images would give you a further enhancement in SNR. And then finally, the 3rd way to use a second camera is to do this cross-match function. So there are trade-offs to doing that, because if you do cross-match, then you won't be able to get that SNR improvement, because the way cross-match works is that it requires the images to be separate, independent. Otherwise, you cannot guarantee the elimination of false detections. So it's sort of akin to doing a follow-up, but doing it at the same time that you're doing the initial discovery of candidate detections. So there's a risk to doing follow-up in that at a later time you might not be able to recover the object if clouds come in, that sort of thing. So sometimes it might be nice to be able to have a sort of a pair of cameras that can essentially do that sort of follow-up at the same time. But it's not a true follow-up, because the arc of the observations has not been extended and so forth. But if you're able to essentially eliminate those false detections and have only true detections remain, then that's a positive improvement. And the other nice thing about it is that it does not depend upon the confidence routine. So most of the time you get a good result with the confidence algorithm, but there are still some objects that might have a low or even a no confidence, even though they are real objects. And that just comes down to the fact that they have a very faint signal. So for example, this one right here, this is a true detection. This is a real object, but it had a low confidence. But the reason that it survived the cross-match is because it showed up in the track file from both cameras. So again, it's just sort of an experimental feature at this point, but it's something to have available in the toolbox. So with that out of the way, that concludes the video. So thank you for watching, and see you next time.